Complex numbers. Well, in this video, our objective is two parts. We want to define what a complex number is, and we want to define what a complex conjugate is. Let's first talk about what we know. We know what an imaginary number is. It's a number that when squared gives a negative result. And here's kind of a little picture of that. This does not exist. The ability to square a number and get a negative does not exist in the real number system. So it's been created and defined by the letter I or the letter J in technical fields, as the letter I believe, has something to do with electronics. And so we define it as follows, J squared is equal to negative 1. Or again, in mathematics, I squared is equal to negative 1. Which means, if we take the square root of both sides, J is equal to the square root of negative 1. And again, the square root of a negative does not occur in the real number system. So now we've defined an imaginary number system. The second thing we know is what a conjugate is. A conjugate is the same two terms with the opposite sign between them. For example, the conjugate of 1 plus the square root of 2 is 1 minus the square root of 2. The same two terms with the opposite sign between them. You've used this to rationalize denominators in which the denominator looks something like this or like this when you've had a radical in your denominator. So what's a complex number? Okay, a complex number is a combination of a real number and an imaginary number. And it's made up of a real part, an imaginary part, and the imaginary unit, which is the square root of negative 1. So again, here's another picture of it. A complex number is generally denoted as A plus BI, or again, in the technical fields, A plus BJ. The real part is the A in front. The imaginary part is the B here, and the I or the J represents the square root of negative 1, the imaginary part. A couple comments to make about a complex number. The A plus BJ is called the rectangular form of a complex number, and we'll deal with different forms in future lectures. Also called the standard form of a complex number. Examples, 1 plus J, and let's recognize there's a 1 in front of that J. We don't have to write it. How about negative 2 minus 4J? Examples of the rectangular form of complex numbers. Complex numbers are all inclusive. All real numbers are complex numbers. For example, the real number 5. We can write that as 5 plus 0J. So 5 while it's a real number, an integer, a whole number, etc., it's also a complex number. We'll just write it this way to show that it's a complex number. And all imaginary numbers are complex numbers. So the complex number 2J, which is an imaginary number, can be written as 0, the real part being 0 plus 2J. And so the imaginary number is also a complex number. All numbers are complex numbers. Okay, the last thing we want to define is what a complex conjugate is, and we'll go back up. I'll come up a little bit here. We'll go back up to what a conjugate is. A complex conjugate, well, that just means that if we're given a complex number, so we're given a number, a real part, an imaginary part, and the imaginary unit, the complex conjugate is the same two terms with the opposite sign between them. So for example, if we're given the complex number 3 minus 4J, the complex conjugate is the same two terms, 3, here, 4J, at the end and at the end with the opposite sign between them. Minus becomes a plus, and this is the complex conjugate. We'll be using that in our next video lecture when we talk about dividing complex numbers. So there you have it.